Hello and welcome, I'm your Code Monkey. Alright, so here let's see a quick overview of everything we're going to learn in the advanced section of this C# course. This is going to involve a lot of very interesting, very unique topics. We're going to start off with an interesting advanced topic that I actually only started seriously using just recently. It's reflection. I had to learn this myself in order to make the exercise for the companion project. Reflection is how you can dynamically inspect your code and work with it without directly calling any functions or reading any fields. Next is going to be a simple but interesting one. It's how you can make some function extensions. This allows you to extend a type with more functions without having to modify that type itself. This is really useful when you don't have access to the type itself, when you don't have source code access. Then we're going to learn about static constructors. These are kind of like the normal constructor, but they run just once for the entire class. After that, we're going to learn about the type of keyword. This lets us get a system.type object of any type that we have. This is very important to use alongside reflection. Then a lecture on name of. This one helps you get a string name for some kind of type. This is really useful to help you avoid strings in your code. Next is the size of operator. This one lets you get the size of your types. Like for example, you can see how an int is 4 bytes, a short is 2 bytes, and a byte is just a single byte. So this helps you know how much memory your code will use. Then a lecture on default. Simple and very useful way to get the default value of some type. If you do the default of an int, you get 0. If you do the default of a bool, you get false. If you do the default of some object, you get null, and so on. So using this keyword is much better than hard coding some default values. After that, we're going to have a lecture on expression-bodied members. This is a really interesting, very compact way to write simple short functions. There's no need to write all the usual function boilerplate code. This one is basically just a lambda. After that, we're going to see a lecture on records. This is a super simple way to create immutable types to organize your data. Next, we're going to learn about the null conditional operators. This is how you can easily test for null before doing something, like for example, before firing off an event. Then a lecture on the null coalescing operator. This one lets you quickly test against null, and if it is null, return a default value. After that, we're going to learn about the ternary conditional operator. This is an excellent, super compact syntax for making a very simple if. You have the condition with an if and an else, so it's all very tiny, very useful. Next, we're going to learn about the main function in a console app and how to pass in some command line arguments. This is a really important one because there are many interesting programs that you can build that don't need any kind of UI. So a simple console app that you can control with some command line arguments, that one is always going to be an excellent option. Then a lecture on nullable. This is how you can make any type support null. Even value types like int or bool. You can make them nullable to support null. This can be much better than having to predefine some special value, something like -1. Next, we're going to see a lecture on span. This is a super efficient way to do logic on arrays or slices of arrays. Importantly is how this does not actually create any new data. It does not cost any new memory, does not create a new object. This one is basically just a pointer, meaning it is insanely performant. Then a lecture on bitwise operators. This is how you can work with individual bits of data. In this lecture, I'm also going to teach the basics for how binary works. Next, we're going to learn about enum flags. This is how you can turn your enums into bit masks, which then allows you to make some interesting combinations. Then a lecture on pre-processed directives. With this, we can give orders to the compiler itself. We can define symbols and include or not include some code in the compilation. Next, a lecture on the keywords ref, out, and in. These are really useful. They help you get more data out of a function than just a single return type. And they also help you work with types as references, even if they are value types. After that, we're going to learn about data boxing. Now, this does not have anything to do with punching people. It's really all about putting data inside a box. This is an interesting property based on the fact that everything in C# extends from object. Next, we're going to learn about dynamic. This is a really interesting, very advanced topic. With dynamic, we can work with types that don't actually exist. So we can define something as dynamic and call functions or read fields on that type, on that object, even if they don't really exist. That validation logic is only going to run at runtime, not at compile time. So this dynamic, this is really useful, especially when working with data you got from some kind of web server. Then a lecture on the class indexer. With this, you can make your own custom types, support access through an index, just like a list or array. You can add whatever logic you want and make it read-only or read-write. Next is a lecture on attributes. With this, you can add metadata to your code. Then that metadata can represent whatever you want. You can use reflection to analyze it and do something to it. After that is a lecture on anonymous types. Really interesting, quick way of organizing some data without having to first define a specific type. You just do new, open up the curly braces, and it will automatically create a generated type. Related to that is the next lecture on tuples. These are very similar. They also allow you to organize some data without first defining a type. In this lecture, I also covered the differences between anonymous types and tuples. Next is going to be a lecture on using IDisposable. This is a really interesting code block and interface that helps you make sure you don't forget any kind of cleanup code. After that, we're going to learn how to create custom override operators. Using these, we can add support for our own classes to do things like addition or multiplication. We can define the logic of what exactly it means to add two custom player classes together, and also define the logic for comparing two custom types, meaning defining the logic for what exactly does it mean to do an equals. Next is a lecture on LINQ. With LINQ, we can easily do query operations on any collection of data, whether it be a list or array or some XML or some kind of database. We grab that data, then we can query for some conditions and select just a few elements. We can sort some things, we can do a union and so on. If you're familiar with SQL, then LINQ will be quite familiar. Afterwards, we're going to learn about WinForms. This is how you can make visual C# programs. You have your toolbox and you just drag and drop the components. Here, I'm also going to talk about the other visual program tools, things like WPF and .NET MAUI, as well as how Unity itself doesn't have to be used just for making games. You can make normal applications with Unity. Next is going to be a lecture on DLL import, the library import, how to use extern and work with the Windows API. So this one is going to be a great lecture to learn how to interact with external libraries. Then a lecture on asserts and unit testing in general. With this, you can validate your own code to make sure everything is behaving exactly as intended. Next is going to be a lecture on writing unsafe C# code and working with pointers. Now this is a very, very advanced topic. Technically, if you know what you're doing, you can make some impressive stuff with unsafe code, but C# has a safety for a reason, so definitely only use this wisely. Then we're going to learn about asynchronous programming, specifically how to use async, await, and task. This is how you can have some code that takes some time, like for example contacting a web server, and keep waiting for a response without blocking your program. This is extremely important in making sure your program feels nice and responsive. After that comes a super important advanced lecture. This one is all about multi-threading. This is how you can take advantage of all the cores in a CPU to make them all do work at the exact same time. When done properly, you can get some insane performance improvements, but it is also very, very easy to make mistakes. So this one is very much a definition of an advanced topic where you must know exactly what you're doing. And yep, all of that concludes the advanced section of this course. As you can see, we're going to learn about a lot of very advanced, unique topics. Some of them you're going to use quite often, and some of those probably less often. But just by learning about them, learning that they exist, that will help you whenever you need to use them. And of course, remember how you can always come back to this course at any time. You're really not expected to memorize all of this. Personally, I Google things all the time, and now actually I have this course in my own words. So anytime that I need to relearn some syntax, I'm really just going to rewatch the lecture to learn myself. So if in the future you want to re-remember something, like for example how async programming works, you can just come back here and watch that lecture. Alright, so this is everything we're going to learn. So let's start learning some advanced topics with the next lecture.